Biot Savart. There are two people. The first, though both are French physicists, and they are Jean Baptiste Biot, Felix Savart. A moving charge produces a magnetic field. So we want a charge which is in motion. A conductor. Let us say this is my conductor, and let us say it can be labeled as X and Y. Current is flowing in this direction from X to Y. We are going to take an arbitrary point. Let us call this point as point P, and if this point is on the right hand side of this current carrying conductor, then according to the right hand clasp rule, it is going to be into the plane of the board. The magnetic field at this point P from this current element. Now there will be some distance from the current element to the point P. So let us take that distance as R. So this is going to be given by a position vector R. If I take this as my direction of the current element, then there will be an angle theta. So I am going to take that angle as angle theta. Now what is that angle? It is the angle between the direction of the current element and the position vector joining the current element to the point P. Don't want the magnetic field entirely from the whole element. So what we are looking for? We are looking for a small part of that wire through which the current flows, and that current gives rise to the magnetic field. So now we are going to take only a small part of the complete element, and this we are going to call it as dl with a vector, because it has got a direction. So what is dl? It is the small part of the current carrying conductor which is going to contribute for the production of magnetic field at this point P. Of the Biot Savart law. So according to Biot Savart law, the magnetic field dB at point P at a distance R from the current element dl is, the magnetic field is directly related to the current. Current increase. If the current increases, the magnetic field increases. If the current decreases, the magnetic field decreases. So the first part of the statement will be is directly proportional to the current flowing in the conductor. So if I want to write it in the form of a proportionality, then it is going to be dB proportional to I. It is directly proportional to the length of the current element. So what I can write as proportionality, dB is proportional to dl. Next, the third part is going to be the relation with this, and it is directly proportional to the sine. What I can write? dB is proportional to sine theta. Then the fourth statement, like as we say for the Coulomb's law, inversely proportional to the square of the distance, the same thing applies to the Biot Savart's law also. So it is inversely proportional to the square of the distance. Distance from the source. So that is going to give me dB proportional to 1 by r square. So dB is proportional to what? The first thing is the current I. The second point is the current length, the conductor length dl. Then it is going to be proportional to sine theta and is going to be divided by r square. So that is the equation or proportionality for the magnetic field as given by the Biot Savart law. Now the first thing that we are going to do here is to remove that proportionality. To remove that proportionality, what I am going to do here is I am going to put a constant for proportionality. So dB will be equal to I dl sine theta divided by r square, mu naught divided by 4 pi. So this is going to be the statement of equality of the Biot Savart's law. This mu naught is called as permeability of free space. Permeability of free space.